North America's giants had vanished. Then, 68 million years ago, their footsteps returned. For millions of years, sauropods had nearly disappeared from the continent's fossil record, while their relatives elsewhere kept growing into monsters. What erased animals weighing tens of tons without wiping out the dinosaurs around them? And if you stood beside the last returning herd, which was deadlier, the predator stalking it, or the giants moving around you? Ground vibration comes first. Then one neck rises above the tree line, followed by another. Dust lifts from the dry ground before the animals themselves appear, and a shallow pool trembles with each distant step. Vegetation bends and breaks in slow waves as the bodies move through it. A smaller animal stays tucked between two larger ones. Something else moves along the tree line, never fully stepping into view. These are late surviving titanosaurs, moving through what is now the American Southwest. And that's exactly what makes this scene so strange. For much of the late Cretaceous, sauropod evidence had become extremely scarce across North America, while many other dinosaur groups remained abundant. Three suspects could help explain that gap: a changing map, ecological pressure, and a fossil record that may be hiding part of the truth. None of them can explain it alone. But before we can understand why the giants disappeared, we need to understand what it cost to become one. The body that made a sauropod almost untouchable carried a hidden cost. Column-like legs supported unheard-of mass. A small head sat atop a neck built to sweep across an enormous feeding radius without forcing the rest of the body to move. Air-filled, pneumatic bones, and an inferred network of internal air sacs likely lightened the skeleton. None of it mattered for show. Every feature bore either survival or appetite. A healthy adult was nearly impossible for most predators to bring down. Teeth simply couldn't reach anything vital through that much animal. But gigantism isn't free. It depends on a landscape that keeps delivering enormous quantities of food, day after day, across a connected range. Beside one forefoot, the whole animal can't fit into view at once. What if your greatest defense required an entire landscape to keep functioning every day? Being 30 tons solves a surprising number of predator problems. It does nothing for the grocery bill. For the adults, size was armor. For the young, it was only a future they might never reach. Back at the herd's outer edge, the smaller titanosaur drifts further from the larger bodies around it. The predator appears only in fragments between legs and ferns. A branch breaks behind the herd, followed by another, farther away. It's studying spacing, not challenging an adult. Dust, shifting vegetation, and the constant movement of legs create blind pockets the juvenile cannot track. Outside the herd, it's exposed. Inside it, it risks being crushed by animals many times its own weight that barely notice it exists. A sudden shift in the group nearly isolates it completely, and still, the predator doesn't commit. What if the safest place in the ecosystem could crush you by accident? Would standing exposed at the edge actually be safer than staying buried beneath tons of moving animal? Yet predators weren't what made sauropods stop. The next threat was larger than any animal, and it was already changing the map. Now move backward to the long period when sauropods began disappearing from North America's fossil record. It didn't happen everywhere at once. In some regions, their bones simply became harder and harder to find. But the ecosystems around them were still alive. Duck-billed dinosaurs moved through the low vegetation. Armored herbivores fed close to the ground. Horned dinosaurs crossed the open plains, while predators followed behind them. The landscape was crowded with dinosaurs, but no long neck rose above the trees. Entire generations of predators and prey may have lived and died without ever seeing a sauropod. The ecosystem remained alive. The giants did not. And then North America itself began to close around them. The next threat had no teeth, no claws, and no need to chase them. Rising seas pushed inland, and a shallow interior waterway split the continent apart, cutting off roots and reshaping entire ecosystems. Feeding grounds that once stretched for hundreds of miles fragmented into isolated pockets. Populations built for wide-ranging movement suddenly found their world narrowing. This wasn't the only cause, but for animals whose bodies demanded that much space, it was devastating. In one valley, shorelines creep forward, vegetation shifts, familiar feeding routes vanish, and giant tracks grow rarer with every passing layer of rock. To grasp the scale of that change, what if the center of the modern United States slowly became an ocean? For these giants, that was already happening. What if every route to food narrowed while their bodies still demanded enormous resources? They couldn't simply need less. One final, massive footprint fills with mud and disappears beneath the sediment. Time moves on. Other dinosaurs keep walking above it, never knowing what lies beneath their feet. The dinosaurs did not stop. The giant footsteps did. The sea may have reduced the giants. It may also have hidden the survivors. Then the rocks themselves created a second mystery. Had the giants really vanished as completely as the empty record seemed to suggest? A body left on a dry upland plain gets scattered, bleached and weathered apart, leaving nothing behind for anyone to ever find. The herd from our opening could cross a valley like that, live there for generations, and leave almost no trace at all. Fossilization requires a rare chain of events, rapid burial, exactly the right chemistry, and millions of undisturbed years. Inland, higher elevation environments where these giants may have retreated are chronically underrepresented in the rock record. So every new trackway or bone can quietly shrink a gap that once looked absolute. That doesn't mean healthy populations were secretly thriving out of sight the whole time. What if part of the extinction happened inside the rocks rather than entirely inside the ecosystem? The fossil record is an extraordinary archive. Unfortunately, most of the pages are missing. The answer may not be extinction or preservation. It may be both. But missing pages can't explain why a different kind of herbivore was becoming more common. The next suspect was not a predator. It didn't need to spill a drop of blood. Duck-billed dinosaurs and their relatives were multiplying, armed with dense batteries of grinding teeth built for efficient, high-volume feeding. Adult sauropods could usually browse above them, out of easy reach. Juveniles could not. Closer to the ground, closer in height, and competing for the very same low vegetation, young sauropods may have been squeezed out by animals that never had to fight them at all. A young sauropod stretches down toward vegetation already stripped low by other herbivores nearby. What if the animal helping to eliminate a giant never had to fight it? How would scientists identify a killer that left no bite mark? There was no herbivore conspiracy. There was simply less room at the buffet. And the body plan itself wasn't failing, because farther south, sauropods were becoming enormous. While North America went silent, the southern world was building monsters. In South America, titanosaurs were reaching staggering sizes during this exact window, with Patagotitan and Argentinosaurus ranking among the largest land animals scientists have ever measured. Long necks kept blocking the horizon there, again and again, herd after herd, as if the whole southern hemisphere had never heard about the crisis up north. The body plan hadn't failed anywhere on the planet. What looked like a global collapse, viewed from one continent, was in truth a pattern shaped by local conditions. Shifting geography elsewhere may eventually have reopened doors that had stayed firmly shut in North America for millions of years, though the exact routes back remain unresolved. What if one continent appeared to forget sauropods while another produced some of the largest animals ever to walk? Sauropods hadn't reached an evolutionary dead end. North America had become the regional problem. Then, after millions of years of silence, enormous bones returned to the North American record. A slow rhythm moves through the ground again, and a head rises above a canopy line that had lacked any long neck for millions of years. Vibration and shifting brush announce it long before the animal itself comes into view. This is Alamosaurus, the best documented titanosaur to reappear in the region. It likely weighed tens of tons, though researchers still haven't settled on one maximum figure, and its exact ancestry and migration route remain hotly debated. Did southern populations move north, or did changing geography simply reopen a route? What's clearer is the timing. As inland seas retreated and the map itself reopened, space and connected habitat returned right along with it after millions of years of extreme scarcity. This wasn't a restoration of the old Jurassic diversity. It was a single foothold, not a full reconquest. It was built from a mix of shifting habitat, incomplete sampling, and possibly eased competition. No single dramatic killer is required to explain any part of it. The giants hadn't reconquered North America, but they had found a way back in. Now the smaller animal from the opening has to survive long enough to inherit that return. The predator closes as the juvenile edges toward open ground, but dust and shifting bodies wreck its line of sight completely. An adult shifts its weight and removes the clean angle entirely. The attempt stalls, hesitates, then quietly falls apart. The juvenile survives, not because it wins a fight, but because the opportunity to take one simply disappears. How do you reach a target when every path leads beneath dozens of tons of moving animal? How many days must a juvenile survive before size finally becomes protection? Size protected the adults from almost everything the ecosystem could throw at them. But for the young, it was shelter and danger tangled together in the same herd. And it only helped the bloodline while the rest of the world kept cooperating. For the first time in millions of years, North America's sauropods appeared to have a future again. It lasted almost no time. For a while, it's easy to imagine a second age of giants beginning. New generations were spreading back out across a reopened continent. They were filling in the empty horizon, one herd at a time. Every threat these animals had faced up to this point came from inside their own world. Shifting geography, hungry competitors, an incomplete fossil record. The next one didn't come from their world at all. Beside the herd, a point of light brightens in a sky no animal can interpret. What if you survived every danger your world could produce, only to be killed by something that didn't come from your world? The impact delivers heat and flying debris in an instant, but the true collapse arrives after it. Ejecta chokes the upper atmosphere. Sunlight fades for months, and plants fail first. The herbivores that depend on those plants decline next, and the predators that depend on those herbivores follow not far behind them. Entire food webs, built across tens of millions of years, unravel in a span too short for any single lineage to adapt to. Surviving the initial blast was never the same thing as surviving everything that came crashing down afterward. The North American hiatus had ended. The sauropods had returned. But this time, when their footsteps stopped, there would be no second arrival. If a mystery this deep in the fossil record keeps you hooked, stick around and subscribe for the next investigation. Because a smaller titanosaur outrunning one hungry predator is one thing. Could Tyrannosaurus actually kill a full-grown Alamosaurus? The bite force numbers and the actual bone evidence tell a far more complicated story than you might expect. And it starts right where this investigation ends.